In my video on relativistic energy, I got really confused. I had some real questions about this. And I'm going to try to at least point out some things that my research shows, and let's see if maybe I get some comments from you about this. See if you're just as confused about this. E equals mc squared. What does that mean? Well, it's energy, and it really shows that somehow we've got, let's take 1 kilogram of mass. Does that mean you take 1 kilogram of mass and multiply that times the speed of light squared? 3 times 10 to the 16? And that gives you an energy value in joules, going back to just general physics stuff. Where does that gigantic amount of energy come from? Is this the atomic bomb or something? Okay, a 1 kilogram mass does it really have that much energy? And does it really, the math that I did before, does it really just boom come out E equals mc squared? I want to have lots of input on this from you, because was I wrong on that? Did I misinterpret? Did I leave some pieces out? Yes, I left some pieces out. This is the popular version of what Einstein said, but it's not all of what he said. This isn't really the complete equation, because the complete equation looks kind of confusing. Now, maybe we can analyze the complete equation and see if it matches something with reality and pick that apart. So, back to my kind of crude drawing board, and let's see what I can come up with now. And mainly, I'm trying to raise questions. I don't know all the answers. I know lots of questions, but I don't know all the answers. And I think the more that you look at information like this, it's better to pose it with questions rather than saying it's absolute fact. Because over and over again in physics, they've said, oh no, we were wrong. Here's the new, improved version of the information. So let's see what we can come up with. Here's my follow up on this information. And I'm starting in the upper left hand corner with this thing, which I'm okay with this amount of it. This makes sense to me, believe it or not. Now, if this seems a little crude, I'm sorry. I've got a new tablet, but it still doesn't work that well, or I can't get it. So, if any of you have a really good tablet that you want to suggest to me, that would be great. Anyway, I'm getting way off the track here. The This differential of E, that means something like the change in energy. And kinetic energy is kind of a change in energy. Here's the regular kinetic energy that we're used to, 1/2 mv squared. So think of this as the change in energy, or the kinetic energy that we pick up. Then here's the c squared, and that just kind of comes along for the ride, because c squared, or c, is a limiting factor. We can't go any faster than that, or that's the assumption. Now, who knows, maybe we can go faster, but that's the assumption. And then here's a little d over here with the m, and the m is not just plain old mass, but it's relativistic mass, which we had a video on that, relativistic mass. And so this upper line here, we go to E equals mc squared. And how do we get from here to there? Well, we do this process called integration, and the integration does take this differential down to E and this differential down to M, but when you integrate a differential, you also get a constant left over, because a constant, the differential of a constant is 0, so you can possibly have another constant here. So when you get to this point, maybe there's some more to it. Here's, before I do that, let me go down here to the kinetic energy. Here's 1/2 mv squared, and that can also be P. M is mass, V is velocity, and P is momentum. P for momentum. Where did that come from? Well, there's a little history behind that, but the physics people say P stands for momentum. And if P equals mv, mass times velocity for momentum, then here's another way to write this 1/2 mv squared, P over 2m. All right, here we go. E squared, what? E squared, mc squared plus p squared c squared. Where does that come from? That's what we're trying to figure out. That's what I'm trying to. This video might be really short because until I get some more answers about the best way to explain how we got from here to there, I might just leave it as a question in your mind. But anyway, if P is mass times velocity, and that velocity is not c squared, I should say, obviously, then this term goes to 0. So if we're not moving, how do we have energy if we're not moving? That still is a problem for me. But anyway, if this P is 0, then these squareds, you take the square root of both sides and you're right back to this again. So there's a piece of this that makes sense. But if the object is moving and it has mass, then we have momentum. And momentum has this property that physics people say it's conserved. So the momentum is conserved in a system. So think of this as describing a system where something's moving. If it's not moving, I'm not sure why we worry about it. But anyway, remember that this M is relativistic mass, and that if this is rest mass, then we actually come up with something 1 over c squared v squared is just 1, and then pretty much we come up with just the rest mass. But where does this c squared come from? Like I said, this is a very short video. It's very off the cuff, and I'm trying to figure out where to go from here. But I wanted to set the stage by having some questions that I could pose to you, and then we'll try to move forward from this. I hope you still are watching this because I made a big mistake. It's not worth redoing the whole video. I'll go over here to the red palette and put a squared right by the P so that you see a relationship to these two terms. Okay, in other words, 1/2 mv squared is P squared over 2m. If you want to do a little algebra, you can figure that out. Thanks for watching for this last little correction.